So hello, I'm solving a problem which is modeling and finite element analysis of a connecting rod using suitable software package. So for the connecting rod, uh, for the connecting rod analysis, first of all, I am going to draw the connecting rod, which is two part. One is connecting rod and another is rod, connecting rod cam. So first of all, I am going to draw the first part. So for the first part, I am going to sketch and select sketch and then select front plane. After that, I am going to draw two circle. One is from here and the other is from the same center. And then I'll give the dimension for both the circle. One is 45 and other is 33. After that, select this option and then again I'll draw two circles from the same center but different distance. Here one, another one. Now give the dimension. One is 72, another is 54. After that, click the right option and then I'm going to draw a center line. Draw a center line from here to here and then press OK and give the distance to the center line, which is around 201. Okay, then I'm going to draw a line from this circle to this circle. Let's exit. Then I'm going to mirror this line, mirror about this axis, mirror the line, mirror about this axis. It shows this mirror happen, and then I'll give the dimension from this point to this point is 20, and again from this line to this line the angle is how much is 6. And right click and now I'm going to extrude this. First of all, I extrude this part. For that, I'll choose mid plane, give the distance 38, and I'll select this part and this part and press OK. Again I'll go and select sketch and extrude. For that, I'll select this part and this part and give distance 18. Select midplane. Okay. So this part come and then I'll go for sketch again. Select this, select center line, and then I'll draw a center line from this point to this point. Exit, and then I'll select slot for making a slot in connecting rod, which is in the rod, in the middle of the rod. For that, I'll select the midpoint to the side and then draw a slot. Then give the dimension. This dimension is 98 and give the dimension for this radius, which is 8. Select and then go for, now we'll cut this slot into the beam. So that I'll select extrude cut, select blind, I'll give distance, it is very small, so that I'll give 4 and then select OK. And again, now uh, I need to mirror this extrude cut, so that I'll select mirror option, mirror. I'll select mirror about front plane, and then OK. And again, now I need to fillet this corner edges, so that I'll select a fillet. I'll give fillet uh, in 1 mm and select all the edges for this slot. Select this and select this and OK. So it's come. And again, uh, now I go for the sketch and edit the sketch. For that, I'll draw a line from here to here. OK. And then now trim these lines. OK. Then OK. Then this option. And now extrude. Extrude. OK. So this is almost done, and after that I'll select a reference plane, go to the features, go to the reference plane, go to the plane and select the lower plane, give distance 30, select flip because we want to draw the sketch in that side, so that I'll right click and then sketch on the plane. I'll select a slot, which is center point slot, draw a slot, and then again I'll go to the dimension, give dimension 76, give radius 9, enter, and then OK. After that, go to extrude and then select up to surface, select this, select OK. And then we need to cut this, so that for that I'll select sketch, I'll select convert entities, go for features, extrude cut, and OK. Sorry, I'll select this, extrude cut, select this, throw all, select, so this cutout will go out. So now again we'll draw sketch, select this bottom plane, and here we need to draw a circle from the center and from this center, and give the dimension, if the dimension is 9 and here also 9, both 9, and then right click, then go for features, extrude cut, through all, right click. So now our fast modeling is almost ready. We need to fillet. For fillet, first of all I drag and drag to the upper side and set in here. Now I need to give fillet. Fillet is first of all 40 in this edge and in this edge. This edge. Okay. Again, fillet 22. 22 fillet will give in this face and in this face. Let's click right here. So our model is almost ready. Drag down. So this is our first model. So I need to save it. Go to File, Save As, Save As. No, I need to connecting rod upper body. Rod, connecting rod. I'll save it. Yes. Maybe save. Again, go for new part, part modeling. Okay. Now I will go to draw the lower part for the connecting rod, which is cam. For that, I'll select front plane, go to sketch, and then front plane. Here I am drawing two circle, and then select deep dimension. It is same as the circle in the upper part, 72 and 72 and 54. After that, select OK, select line from here to here, select line and then trim these lines. After that, OK, then go features, extrude boss, select mid plane, 38, 38. After that, go in features, select reference plane, select this plane, it is 60, flip on this side, again this side, sketch, select slot, center points, straight slot, center point straight slot from here to here, from here to this side, select slot, give dimension, it is 76 and this is 9. Enter. OK, go for extrude boss, select up to surface. I'll select up to surface and then select this surface and OK. Now again I need to cut this and then convert entity, then go for features, extrude cut, then select here through all and right click. Now right click. Now sketch, select this, select the circle, draw a circle from here and here, give the dimension is 9 and this dimension is also 9, and then select here, select extrude cut through all, right, again sketch, front plane, sketch, select this line, select here to here and here for make a cutout and draw a center line from here to here. Draw, select this thing, mirror. Okay, go for features, extrude cut, select through all both and right. So now our modeling is almost ready. Now I will give fillet. Fillet is 10 mm. Give 10. Select this and this. Again select fillet. Give 3 mm and select this edge. Okay. So our model is ready, which is cam, which is same as cam. Okay. And I'll save it. Save. Now I need to go for assembly. Here new assembly. Okay, so I'll assemble this, connecting this and this. Okay, assemble this thing. For that I need to rotate the lower connecting part. So now I'll go for mate, select mate. So I'm going to mate this. I'll select this and this, and again. Okay, again I'll go for mate, select mate, like this and this, mate, again select this surface and this surface and select mate. So this is our connecting rod model. This is connecting rod. So I'll go for, now I'll go for save it. First of all I'll save this file. For that, go to file, save as. For analysis I'll save it as IGS. Here this is IGS type, and then I'll save as name connecting rod main. Okay, main part, main part. Now I'll go for analysis. For that I'll go in our now I'll go in Ansys part. First of all I select structural, static structural for analyzing this connecting rod. Here this is static structural. Now I'll import the geometry. Right click in geometry and import geometry. I'll browse the geometry part. This is my geometry part. Now click open. These are the engineering data. I'll select general material for this. These are engineering data and go for geometry part. And now I'm right click in the geometry part, go in design modular. Okay, now generate the design modular. Here two parts to body. I'll make it one part. For that I'll choose both the solid and make it from new part, and then generate, then cut it. Then in model right click here. After that I'll select update the model. After that I will select model and then edit option. So here as we can see our model option is open, and then after that, as we know, this is the connecting rod, and this part connecting rod, as we know, connecting rod is always subjected to compressive load. So when compression take place, piston push in the downward direction. That's why there is a compressive load is applied in the connecting rod from the upper side. So for that we assume that now we assume that our connecting rod is not rotating. So for that we need to fix some part from this model. Now for that select for that now I'll make this part as fixed part, and this part will apply the force. So for analysis something we need to do first meshing. For mesh I'll select mesh, and here we need to change the size of the mesh. For that I'll go for sizing, and then I'll select transition as slow, span angular, chorus to fine, and quality smooth to high. Okay, then I'll generate the mesh. So our meshing is generating. It takes some time. It's completed. After that, I need to give boundary condition. So for that, I'll right click in the structural. Here I'll insert, because I want to this uh, fix this portion. For that I'll select fix support. Here this is fix support. I'll select this and this as a fix support, and then I'll apply. Again I'll go here insert, and force I'll give force, because this is in connecting rod there is compressive force applied from the upper side. So I'll give force on here. So I'll select these two face and apply this as a here. This is a magnitude. We can change only one thing, but we can't change in the direction here without direction, so that we can change it to component. And in component, as we can see, this connecting rod in the y direction, and force applied in the y direction, but force is applied to the downward direction. For that we can apply the force in y direction in negative, so that we can apply in negative y component and apply force. Suppose I take 1700 minus 1700, and I am applying the force here. After that I'll go for solution, and now I want to show deformation, which is total deformation, and I'll I want to show stress, which is equivalent stress, and also I want to show strain, which is equivalent strain. And then now I'll solve this. So solution and solve. So now solving this, where will apply the where stress is maximum, minimum, total deformation is minimum, maximum. These are coming from the analysis. So this is 7. Now we can see this is the total deformation, and this is the equivalent stress strain. Now we can see this in wireframe. So I select this. As you can see, this is the wireframe. Here in the red area, here the maximum deformation is applied or happen, and here which is the blue part, here minimum deformation is applied. So blue is minimum because here fixed support of the connecting rod, so that blue portion is minimum, and this portion is elongate, or then compressive force apply on it. So here maximum load is applied. So this is red. As we can see in this way, we see this compressive load is applied, and this is the analysis of the connecting rod. So this is the total deformation, equivalent stress, and this equivalent elastic strain. So thank you. This is the analysis of connecting rod.